Good evening, friends. Now, in gas state, I want to explain about the ideal gas and real gases. Real gases and ideal gases. If ideal gas means, that is PV is equal to nRT. Real gas is not equal to the nRT. Means it is some deviations compared to the ideal gas. First of all, the real gas, when it will come to ideal gas at low pressure and high temperature, then real gas will becomes ideal gas. That is low pressure, high temperature only. It will real gas will follow the ideal gas equation. Next, in case of ideal gas, what we have to consider? In case of ideal gas, the volume occupied by the molecule is negligible. The volume occupied by the molecules in the container is negligible, considered as negligible. For example, if you take this is the container, if we are having these are the molecules, if it is, we consider very small volume, real volume of the gas particles. This is, it is not considered or negligible. But and also the but in case of real gas, the molecules in this case, these are rigid in nature. These are tiny, small particles, tiny in nature, very small particles. But in this case, these molecules are, in case of real gas, rigid. The volume occupied by these molecule is more. That's why the volume in real case, this is considered. It is not negligible. This is considered. But in this case, it is negligible due to small particles are tiny in nature. That's why the actual volume of the gas is negligible compared to the volume occupied by the container. But in this case, we have to consider. In the ideal case, there is no forces of attractions. There is no force of attraction among the molecules. Between the molecule or among the molecule, the forces of attractions is negligible. There is no force of attraction. But in this case, the force of attraction is considered. In this case, the force of attraction is considered, but in this case, ideal gas, there is no forces of attraction is considered because of these are very tiny molecule, these are rigid molecule. This is the main differences of the real gas and ideal gas. Ideal gas, PV is equal to nRT at all temperature and pressure. This follows. But in this case, PV is not is equal to RT, but it follows real gas, it will follows the ideal gas when at low pressure and high temperature, it will follow the ideal gas behavior. But in this case, ideal gas, the volume occupied by the molecule is, the container is negligible. But here we have to consider because these are rigid molecules, these are very tiny molecules. But there is no forces of attractions between among the molecules in case of ideal gas. But in real gas, the intermolecular force of attraction is considered. This is the main differences of the real gas and ideal gas. Next, we have to discuss about the graph. We know according to Boyle's law, we know according to Boyle's law, pressure is inversely proportional to volume at a constant temperature. Pressure is inversely proportional to volume. If you draw the graph, pressure versus V, this is pressure versus volume V. Which graph you have to observe? This is the rectangular hyperbola. This is graph for ideal gas. This is ideal gas. If you take in case of real gas, the slope is height. This is the graph we have observed in case of real gas. What we have observed in this case, pressure versus volume. At a particular pressure, we have to consider this particular pressure. What you have observed, this is the volume of the ideal gas. One, this is the volume of the real gas. What you have observed at particular pressure, the volume occupied by the real gas is greater than the volume occupied by the ideal gas. This you have to observe. But if you take in case of this pressure, what you have observed here, it is the volume of the real gas. This is the volume of the ideal gas. What you have observed here, at this particular pressure, volume of ideal gas is greater than volume of real gas. What you are observed here, at high pressure, the volume of the real gas is greater than volume of the ideal gas. At low pressure, this is the pressure, small pressure, we have two different pressures. At this pressure, low pressure, the volume of the ideal gas is greater than the volume of the real gas. This is we have to observe. We know volume of the real gas is greater than volume of the ideal gas. Expected the ideal gas compared to volume, the real gas volume more means what you have observed? This is the expansion. Then only it will, the volume of the gas will be increased. But in this case, compared to real gas, the volume of the ideal gas is more means this is compressed. The expansion means it is a, from the ideal gas it is a positive deviation. But in this case it is a negative deviation, because it will, the volume will be decreases. From this graph we have to observe what the difference between the real gas and ideal gas, and also their deviations. This you have to remember. Next, this is at a pressure high, this is at a pressure low. These are the two concepts we have to remember. Next, discuss about the compressibility factor. What is compressibility factor? Compressibility factor. The compressibility factor is denoted with Z. Z is equal to, remember, we know ideal gas equation, PV is equal to nRT. The compressibility factor, it tells about the positive deviation from ideal behavior and also negative deviation from ideal behavior, no deviation. Depends upon the value of the Z, it will greater than 1 it is positive deviation, less than 1 it is negative deviation, no deviation means it is equal to the 1. That is Z is equal to PV by RT, nRT, and also Z is equal to V real gas by V ideal gas. These you have to remember. These are the equations of for the compressibility factor. If Z is equal to 1, no deviation, means it is ideal gas behavior. If Z greater than 1 means V, if you put here or here, whatever maybe, PV is greater than nRT, and also V real is greater than V ideal, means this is a positive deviation. If Z is less than 1 means PV less than nRT, V real is less than V ideal, means it is a negative deviation from ideal behavior. This is about the compressibility factor. What is compressibility factor? What it speaks about? Next, what is the formulas of the compressibility factor? If Z is equal to 1, what will happen? If it is PV is greater than nRT and PV less than nRT, and also by using this graph, we can easily find out the which one is ideal gas or real gas. It is either positive deviation or negative deviation. Then we discuss about the uh, ideal gas and real gas, some of the equations. Next, I have write the given the formula Z is equal to V real gas by V ideal gas. E ideal gas, it can be calculated. It can be calculated by using the formula, that is, but this is experimentally determined or already given and measurable. This is experimentally measurable, but this can be calculated by using already. This is experimentally determined the real gas, but V ideal gas is it can be calculated by using this formula PV is equal to nRT, that is V ideal gas. This is about the compressibility factor, what is real gas and what is ideal gas. Next, we write the one of the formula. At STP, 1 mole of a gas occupies 22.5 liters of volume. Then find out the deviation and forces of exist in the gas molecules. Which type of forces are exist in the gas molecule? This is we have to find out. What will happen? You know, Z is equal to V real gas by V ideal. This is experimentally given. At STP, 1 mole of gas occupies 22.5 liters volume. Means this is determined experimentally. That is V real gas. This is 22.5. 25 liters. Whatever it may be, no problem. Okay, this is experimentally given 25 liters. Means this is 25 liters. Next, we know formula. Any gas at standard temperature and pressure, 1 mole of gas occupies 22.4 liters. This is standard one, you have to remember. This is the ideal gas, that is V ideal, 22.4. Less than 1, greater than 1. This is Z is greater than 1. Greater than 1 means V real gas is greater than V ideal gas. Means the volume of the real gas is, the volume of the gas is compared to ideal, it is more. More means it is a positive deviation. Means due to the expansion. Expansion means expansion only, then only the volume increases. When it will happen expansion? Due to repulsive forces. Due to repulsive forces exist in the molecule, then only it will expand. This is the deviation from the V real gas is greater than V ideal gas. This is a positive deviation. Due to the expansion only, then real gas will expand. That's why there is a force exists is repulsive forces. Next. Next, I will give some of the next variation of Z with pressure. Next, variation of Z with pressure and temperature. How to remember? If you take, for example, if you take the graph, this is the graph. This is the y-axis is taken as Z. Z-axis is taken as a pressure. This is the ideal gas, standard one. If you, in case of hydrogen and helium, this is the graph. In case of nitrogen, this is the graph. In case of oxygen, this one. In case of carbon dioxide, this is. For the hydrogen and helium, for what you observe, for hydrogen and helium, at all temperatures and pressure, it will show positive deviation only. At all temperatures and pressure, for hydrogen and helium, it will show positive deviation only. But in case of remaining gases, this is the one. In case of, for nitrogen, carbon dioxide and also the oxygen, at low pressure, it will show negative deviation, and at high pressure it will show positive deviation. These we are observed. We know Z versus pressure graph. For hydrogen and helium, at all temperatures and pressure, these graphs will show positive deviation, but in case of nitrogen, carbon dioxide, at low pressure it is negative deviation, but high pressure it will positive deviation. This is what I explained about this by using this graph. Next, to take example Z versus pressure for gases A, B and C. What you observe? If you take the graph, this is Z versus free. If you take, this is A, this is different gases. This is A, B and C. What question will ask? Arrange the gas AB in order of increasing attractive forces. Arrange gases A, B and C increasing attractive forces. What you observe? This is the graph. This is the one graph, this is two graph, B graph, this is the C graph. This is more negative deviation. Which one? First we have to observe which is more negative deviation. C is more negative deviation. More negative deviation means, we know positive deviation means expansion. Negative deviation means that is attractive forces. In case of positive deviation, repulsive forces. If you observe C is having more negative deviation from ideal gas. This is the ideal gas behavior. That's why C having more attractive forces compared to B and compared to A. This is the arrangement of the forces of attraction between the molecules. Next, versus temperature. Next, you take one more example. Z versus pressure, but by using different temperatures. We have to Z to take pressure P. We write the graphs. No. Take, this is the T1 graph. If you take, this is T2, T3. What will happen in case of, if pressure, in case of what will happen at particular pressure, if temperature increases, the deviation means the real gas will approach to ideal gas behavior. Means if that is T1 is greater than less than T1 2 is less than, higher temperature increases, this deviation from real ideal gas will approach to the real gas will approach to the ideal gas behavior. After higher temperature, it will give positive deviation. This is about the, this deviation is decreases by increasing the temperature. This is about the ideal and real gases behavior. Thank you, friends. Thank you.